Okay, let's do a recap of yesterday. So yesterday, before we ended, we went through DHCP. So I showed you how we can create the network from spaces, from the IPAM portion, right? So we go into the spaces, we create a network, and then from here we create the pool, right? And then we set this pool with the advanced click on it, edit, right? We set this pool to create a DHCP range, and then we were able to get an IP from here. There's one more thing. I showed you on how to get the client assigned with a specific IP address based on its MAC address, okay, which is via clicking on this IP and then putting in a MAC address, right? You can see here is a DHCP static, and it's reserved, which means this MAC address will only be assigned this IP address. So what happens if you want to add MAC addresses without assigning a specific IP? We call that DHCP static without IP. This is DHCP static with IP. Okay, in order to do that, you need to head to the server at the DHCP under Smart. From Smart, you straight away click All Statics. So you can see here, I added a client over here with this MAC address. I give it a name as static no IP. So this MAC address is registered on this particular Smart DHCP server. So anytime this client connects to the network, he will get an IP. Okay. One of the use case for this kind of setup is in an environment where you want to only allow a specific registered MAC address to get an IP address. Those MAC address or devices that is not registered will not be able to get an IP address. Okay, for example, a captive portal, right? I think I've showed this to Yuha previously. The user connects to the network, gets a temporary IP, he registers himself to the network. Once he clicks submit, his MAC address will be captured and added into this list. Right, so this list will be an allow MAC list. So anything that is already registered in the network will be able to obtain an IP address from whichever scope. Right, so any of this scope, when the client connects, he will get the appropriate IP address for the network which he is connected to. Okay, so in order to add this, you just need to click add. Then the scope, you select none. Okay, and then over here, you just give it a name. Then enter MAC address. Okay, then click OK. So the next moment when this device gets connected to the network, immediately he will get an IP address assigned to it. Okay, any questions so far on DHCP before I proceed to DNS Guardian? So today I intend to cover DNS Guardian, GSLB plus net change. We'll try to squeeze as much as we can quickly. If there's no question, I will proceed with DNS Guardian first. Briefly, what is the technology about? So DNS Guardian is a feature of the Efficient IP 360 DNS security. So apart from Guardian, as you can see here, we have the basic, which is solid server. This one. We have the cloud. We have the firewall, DNS firewall, which provides the data feed containing the list of domains from CNC sites, phishing sites, crack sites, and malware sites. This is a subscription-based service. And then we have Guardian over here, which is the behavioral analysis. So it acts as a whitelist for normal clients. The behavior of normal clients is whitelisted, but as soon as it detects something out of the scope or out of the ordinary, he will be able to apply policy on it. So we will go through Guardian now. And then the BLAS is our high capacity solid servers. We are looking at from 1 million QPS to up to 17 million QPS onwards. Right, this is where our BLAS platform is catered towards service provider. So what is the Guardian? So Guardian, the ultimate goal of DNS Guardian is to ensure the DNS service continue to provide its services even if it's under attack, right? So it basically adds a layer between the DNS service. In this case, we are running bind or the unbound. It acts as a layer in between the traffic that's coming in and the DNS services. So this Guardian actually acts as a DNS service layer where it has its own cache, right? And then once the query comes in and there's a cache being stored in that is being matched in the DNS Guardian, it will be able to reply without the traffic reaching the DNS service, right? So that's why we can apply policy at the DNS Guardian portion. So which appliance can support DNS Guardian? So almost all appliances can add the DNS Guardian, right? Hardware appliance, virtual appliance. And then the BLAS series comes with DNS Guardian by default, right? Which is the model 4070, 4070 onwards, basically. Right? And the smart features that it has is cache management plus adaptive DNS security, right? So this is the hardware appliance versus virtual appliance, the number of max client entries for each model. This one, we not really so much for you to take note of it, because at the end of the day, I will be the one that is going to help you size accordingly. So this is just for reference. So DNS Guardian is normally used for a recursive only DNS. Okay. Why is it only for recursive? Recursive DNS consumes resources, a lot of resources, when it's trying to resolve a particular domain. Okay. For example, when a client asks for www.google.com, right? Instead of going to the google.com name server to get the answer, a recursive DNS will need to go from the root, and then it asks .com server. Once it asks the .com server, it will then ask where is google.com server, and then finally it can reach google.com server and ask what is www.google.com. So a single query can make 2 to 3 or 4, maybe more steps to find the answer for the DNS server to work on. So that's why DNS Guardian is created such that we try to prevent a lot of recursive queries from taking place. So anytime there is a cache already available in the Guardian, we'll straight away return it to the client. Only for specific things that do not exist in the cache will it allow recursion to take place. So this is where we can apply the policy, right? So this diagram will show you better. So remember that Guardian is a layer between the DNS service. So the client query reaches the Guardian service. It has its own cache over here, right? As long as the response is not in the cache, it will send the query up to the DNS engine, which will perform the recursive query, right? Once the answer is replied, this guy will also cache the response and then sends it over to the Guardian, which will then cache that response and then provide the response back to the client. Okay, so what happens when the cache is already there? So the client asks, goes through the Guardian service, checks the answer is in the cache, straight away it will reply. Okay, so having this Guardian is the one that allows us to have a high number of QPS for our BLAST models. So this is the primary service that allows us to achieve that high number of QPS. Okay, so this is just architecture, right? You can deploy as a VIP, and then the traffic will always go to the active one. This is just a rollout scenario, not so much on the Anycast stuff. Okay. Okay, I will skip the Blast series. This one is more on the high performance platform. To install, again, this is enabled by the license module. So you need to have the appropriate module license for it. So once you added the license, you configure the local recursive DNS. By default, it's already set with a root hint. And then you select the interface where the Guardian service will start to listen to, right? And then you configure the DNS Guardian, which means you apply the default policy, which is already installed. Okay, so the DNS Guardian administration, as of version 7, can be done via the web GUI, right? So there's no need to access the CLI. We only access the CLI when we need to access some information. For example, this show cache limit, show the client IP, all this needs to be performed via the CLI. Okay. So when you install the license, you will see this as DNS Blast, right? It will not show DNS Guardian in here. This is a legacy thing, right? So as long as you see DNS Blast, it means the appliance or the license already include DNS Guardian. So configuring the Guardian is the same. You create your DHCP server, whatever architecture that you set. Normally for recursive, we set into multi-master because they are not authoritative of any zone. They are just performing recursion. And then you deploy. Yeah, so you can see once you added license and Guardian is enabled, you will see this Guardian column enabled. But of course, you need to assign to the interface that Guardian is supposed to be listening to. Right, so this is the smart architecture again, and these are the physical or virtual DNS servers, right, set with a role of master. So this is a multi-master smart architecture, you can see here. And then you scroll to all the way to the right, you will see more information, and this is going to show you the Guardian GSLB column, and it shows enable. Right, so this is as a forwarder of local DNS engine. So these three Guardian is just forwarding to a backend DNS server to resolve, which is also working. So instead of using root hints, you can also do a forwarder, right? It's the same recursive way of resolving DNS, and the DNS Guardian can still work. Okay, so in order to do forwarding, you just need to select the smart architecture and add your forwarder DNS IP over here. Okay, the DNS Guardian also support views, right? Because bind has views, so the DNS Guardian also has views, but the number of views is limited to maximum of 8 views, because that is the Guardian limitation. So in order to support views, yes, the DNS Guardian can support, but anything more than 8 will not be supported. Right? So you need to be careful when you deploy Guardian on environment that has more than 8 views. Okay, yeah. So 8 views is the maximum that can be processed by DNS Guardian. So if views exist, you cannot switch to unbound. right? So I mentioned this yesterday. Yes, we have hybrid engine, but there are some settings that will cause the hybrid engine to not work, right? Or not possible at all. So be very careful when you deploy solutions to your customer environment. Okay, I don't want to go into this detail yet. I want to go straight to the policy so you know what is going on. This is just the view. The list. DCM, centralized management. Okay, so to enable the Guardian, right, you need to click on this under services. You will need to click on the Guardian. Okay. Sorry. Okay, you need to click on the Guardian, enable it, and then before you can start, you need to select the listening interface, right? The interface where the DNS traffic will be coming in, right? Guardian is designed to listen to specific interfaces, so you need to decide. If you don't set the listening interface, then Guardian will not work at all. It will just pass through the traffic straight to the DNS engine. Okay, so from the main dashboard, you can see whether Guardian is enabled or not enabled under the general information, right? And this service configuration is accessible from the CM, right? And each and every DNS server needs to be manually enabled for this Guardian to work, right? So if you have a CM, then everything can be done through the CM interface. So once you have enabled the Guardian on the smart architecture, you will see a lot more statistics, right? So by default, you can only see the simple DNS server statistics, but once you enable the Guardian, you will see much more, right? And then the options also can be, they have more options there where you can set DNS Guardian's stuff, right? This options configuration is under the smart properties, right? And then these are some of the options that's available. This is very, very technical, and usually we don't touch this. This is usually on use case by case basis. So typically the professional services will do any customization based on the environment, right? From a POC perspective, usually we very rarely touch the options configuration. Okay, so there are three options. You can display all using non-default values, means values that has changed, and using default values, the values that is using default ones. Right, so you can easily filter out which one you want to see. Right, so these are some of the settings that can be changed: the max cache entries and the max client entries. Right, these are some of the values that can be changed or modified according to the environment. Right, and the advanced options will show this change. So when you make changes to the max cache entries and max client entries, this one will show or appear in the options portion of the properties page. This is the filter when using non-default values. Right, so the advanced options will show where is it inherited from. So if you see the max cache entries over here, it shows from smart, which means it is inherited from the smart architecture. Right, it is inherited from smart architecture, and this is the DNS server. When you click the properties, it will show this as inherited. So if you see an entry over here that is not having a from smart, which means it is not inherited and it was set on the DNS server level. Okay. So some CLI entries that can be executed, I can copy this and share with you. Once we have ended training, I will share everything, the link to download the ISO plus all the necessary commands to help you get started with a test in your lab. Right, these are some of the CLI commands that we use. So most of the important commands is usually set, load, save, and show. Right, usually it's show clients or show triggers to identify which client has been blocked or in quarantine. Okay, the commands are somewhat similar to sys4 kind of syntax, right? So it's not that difficult actually. Right, so this show config. So whatever configuration that has been set on the UI, and when you run this on the CLI, you can see the same configuration being displayed. Okay. All the settings that was changed will also be shown here because it's the configuration. These are some commands. So you set +0 means you disable Guardian, right? Set +1 means enable Guardian. Save config, save the configuration to this particular file in data1 etc dns plus conf. And you can also load the config from this Guardian config file. Okay, let me jump straight to the policies, which will be more interesting. This is too detailed. Let me go to the policy. Okay, one of the unique feature for DNS Guardian is if you have a lot of DNS servers, particularly in the ISP environment, it is possible to share the cache, which means it is syncing the cache with all other DNS servers, right? What this thing tries to achieve is it helps the user to achieve low latency when they perform the queries. And it also limit the risk of cache poisoning because all the DNS server will have the same cache being shared across them. So one of the benefit of this is in environments, in typical environments, right, in ISP, what we have observed is almost 90%, 90 to 95% of the queries are responded by cache. So it's very, very low recursion once the cache is populated. So this is why it is good to have the cache being responded by the Guardian because we reduce the possibility of a recursion done by the bind every now and then, right? So this is where we have a very high performance server for the service provider. Okay. Just want to go straight to the policy, which will be very, very interesting. Okay, so the logs. On the Guardian, we have three kinds of logs that can be generated. But when you enable these logs, you have to be very, very careful because these logs will be written to the disk. So when you have stuff being written to the disk, that is additional performance impact, right? So that's why we only enable this logging for troubleshooting purposes, right? In production environment, we don't want to enable these logs, right? So the first standard log we have is query logging. So any queries coming from the client will be logged into the syslog called named.log file, and you can see the queries, what are the queries being performed by the client, right? To know the answer, what the DNS server is responding to the query will be in the answer log, and it's the same named.log file. So you can now see what is being asked and what the DNS server is returning, right? This is very, very tedious in a very high capacity environment. So be very careful. And then list log, very rarely being used, but it's just to log the query and the name of the list when the domain query matches a list, right? So it will just show this domain matches which particular list, right? This is enabled via the GUI and also via the CLI. It's possible to do that. Okay. Let me, yeah. So this is the setting where to enable the query log and answer log on the GUI. So it's under the properties and under options configuration. So under smart architecture, you click on properties, you will see options configuration, click on it, then you will see this window and you can set either query log or answer log, yes or no. Okay. And these logs can also be viewed on the GUI. So you just need to head to administration syslog, select the service. In this case, DNS is named, right? And you can see the logs from the GUI. And one of the good things about the GUI is you can also filter, right? So you can see this text field over here. You can filter the time and also the entry in the logs. So for a specific domain, you can just enter, for example, phantom, right? And then it will show all the lines that contain the word phantom. Okay. Okay, when you have environment where you install a authoritative DNS, right? There is a very big sentence over there. However, the Guardian does not offer any protection to the authoritative function. Okay, if you want to deploy Guardian on a DNS server that performs both recursive and authoritative services, you still can. But Guardian will not protect the authoritative function, right? It will only protect the recursive queries. Because at the end of the day, when a client requests for an authoritative answer, the DNS server is able to provide immediately without doing recursion. Right? So Guardian having there is defeating the purpose, basically. Right? It is still possible, but it does not protect the authoritative function. Okay. So this is the reason why. So client query the DNS Guardian. DNS Guardian does not have it in the cache. It will ask the bind. Bind has the authoritative value, returns, cache the DNS Guardian cache the response, and then sends it back to the client. So again, the Guardian is not doing its proper job, basically. Okay. So the best architecture is to separate the cache or the recursive from the authoritative, and it's also the best practice approach. And when we deploy, usually we want the client to hit the cache or the recursive DNS, which has Guardian in there, so that we can see the IP address of the client and we can control him, right? So that is the typical deployment on how we deploy the DNS Guardian solid server. Right. So when you use Guardian on both a recursive and authoritative DNS server, you need to set this flag. This is also under the options configuration. You need to set this flag as both, so that Guardian is not blocking the queries. We have seen some issues with not configuring this flag properly, where the authoritative answers are not being responded to. So this is one of the things that we need to take note when you deploy on the same appliance, both authoritative and recursive. Okay, this is a telco use case. I'm gonna switch to another file. Okay, let's go through the use case. This one will be very, very interesting, so you understand what Guardian is doing. So just now was configuration. So this is use case analysis, the top 5 DNS attacks and how Guardian is able to mitigate these attacks. So DNS tunneling will be the first attack, followed by data exfiltration, DOS, and best practices. So introduction, right? So the top 5 attacks, hold on. Top 5 attacks we'll be covering is this. So denial of service itself has other names, sub-names for it, which is invalid query, phantom domain, sloth DNS attack, volumetric. These are all considered under DOS attacks, right? And one thing to note about DNS Guardian is we do not identify the attack by its name, because we don't rely on signature, right? We need some customers to be very clear on this. We don't have a signature to identify, oh, this is a DNS tunneling attack, this is data exfiltration attack. No, the Guardian acts by observing the behavior of the DNS queries and then apply policies that match the triggers. Okay. So typical architecture that will be used in the next slide. So this is a best practice architecture. So user with privileged access has the Active Directory plus internal DNS. You have the DNS resolver in there. Public DNS is the public facing DNS on the for this company eCorp. And then there's also the public name servers or the root servers hosting the name servers for the zones. Right, and we also have a eCorp server on the left, which has the confidential data in there. So public user will query the public name servers, and then finally the public name servers will point them to the public DNS hosted by ecorp.com containing the record www. Okay, this is authoritative DNS. For the user within the enterprise or organization, to get to salesforce.com, he will ask the DNS resolver, and the DNS resolver will then query the public name servers to be able to resolve to salesforce.com, and that answer will always be cached. So this is a very typical scenario. So what happens if there is an attacker, right? For some attacks, the malware is spread by a hacker sending an email, for example, right? And the user clicks on the link, and once the link is executed, the attacker is able to create a control channel between itself and the laptop or the PC, and then it can perform whatever stuff that it wants. Right, so basically this is how a typical phishing attack takes place. You can sometimes you will receive this email containing a very closely related domain name, which looks like a legitimate one, but actually if you look very closely, it doesn't. So we have to be very careful, and once that happens, the attacker might be able to control your laptop. So how they do that? Through DNS tunneling. So I will share with you the mechanism of DNS tunneling and how we can set up a trigger to detect DNS tunneling attack. Okay. So how it works? DNS tunneling uses DNS as a media, right, to bypass the typical firewall, because firewall will always allow port 53 outside to the internet to do resolving. And this is why attacker uses the DNS to create a tunnel to its server, right? So this client, attacker accessing internet from his laptop, creates a tunnel using DNS queries to this DNS server, and this DNS server, acting as a recursive DNS, will perform its job properly by doing recursive lookup. And that zone that this attacker provides is pointing to its own DNS server hosting that particular zone, which then translates that packet into web traffic, for example. And this allows this attacking client to access internet through this server, bypassing whatever restriction that the environment has, right? And because it's DNS queries, it's seen at a DNS query, it passes through. So these are the flaws. So DNS protocol UDP port 53 is not blocked, right? You can block email, you can block HTTP, HTTPS 44380, but UDP 53 is always not blocked. And then hacker use this DNS tunneling utilities, iodine, if you want, you can test it out using iodine to create a tunnel, and then sends a request, DNS request, encoded in this format to the zone that is hosted by the attacker. So from a firewall perspective, they don't do deep packet inspection or DNS transaction inspection of this query being performed by the client. So that's why they will just let the query bypass and then head straight to the internet. And this is made worse by using eDNS. Right? Most of the DNS server right now supports the eDNS. So eDNS is an extension. At the current moment, it's version 0. So this extension allows UDP packet. Right now, it's only 512 byte, but with eDNS extension, it is able to allow to up to 4096 or 4 kilobyte of data. So if you ask me, 4 kilobyte of data is pretty huge for a query, right? And this is what the hacker normally uses to send data out to the internet. Okay. So this is how it works. So attacker uses the proxy, which is this tunnel server as a proxy, to send HTTP requests through the DNS tunnel, right? Which will then encode this request as a DNS query, sends it pass through the firewall to this server. This server will then decrypt it, change it back to the original request, gets the data from google.com, and then replies back the content to the client. Okay, this is the query of sending. This is the query, the response sending mechanism. Right, so the content of the HTML page is now downloaded, encoded back as a DNS response, and send it down to this DNS server, who will then cache and reply to the client. Okay, so typically it will look like a DNS query. Right, the client sends a query, you get a response, and then it sends another query, it gets a response to the firewall. It is just a DNS query. So how do we attack? How do we detect actually what is going on? So DNS tunneling, right? The encoded value itself is unique. Okay, each request is unique. Right, like I mentioned earlier, typically the service provider is observing a cache trend of about 90 to 95%. Correct. So typically all the queries should be responded by the cache and very low recursive requirements. But now when you have DNS tunneling, you can see that each request is unique, which means it will never hit the cache. This is something that we need to take note of. Why is it not hitting the cache? Firstly. Secondly, the packet size of the request is higher than average. Right? The size is always higher than the average, it's longer than average. Then the first one is always abnormally high traffic from the client, because each request is unique and each request is an encoded value of a HTTP web request, for example. So it's abnormally high traffic from the client. So with all these symptoms that we see, plus high number of queries requiring recursion, because it is always not in the cache, these are the fingerprints of a DNS tunneling, right? So the next question is, how do we block? Do we block the zone, tunneling zone, or do we block the client, right?